Alright, today I'm going to talk about the LM7805 voltage regulator. If I can zoom in here on my breadboard, you'll see that's my 7805. They also make a different package for it. I believe this little guy will give you a half of an amp. The larger one, unheat sinked, will give you 1 amp. With a heat sink, it can give you up to 3 amps. And let's see if I can focus back here. You'll see my protection diode. And right now I have 12 volts coming in through these jumper cables on my right, and I'm supplying my Arduino with this LCD shield with 5 volts. So I have the schematic for you guys. I actually had the breadboard blown up here and a schematic. But you'll see this is showing 6 volt input, and it's going into the top rail to power the top rail of the breadboard. Here on the left you'll see the voltage regulator, and below it is a protection diode. What the protection diode does, the 1N4001, it only allows current to pass in one direction. So, let's get my mouse here. So if I would reverse the polarity going into this diode, it will act as a dead short. But right now, it has positive on this side and negative on this side, which its bias will not allow it to pass current. So it's basically invisible in the circuit. Like I said, if I would, let's see if I can reverse this. If I would reverse it like this, don't mind the rat's nest wires there, if I would reverse it like that, this would go up in smoke on my circuit board because it's allowing a dead short to pass. Okay, I got rat's nest there. This is the LM7805 regulator, and this side over here, okay, this is showing output voltage on this side, which is incorrect. Your input voltage is on your left. When you're looking straight on at the chip, and this little shelf, you can see the shelf and the numbers are in front of you. The input voltage is on your left. So this is not an LM7805, this is a more generic voltage regulator. The center and the heat sink are both ground, and the right is your output voltage. So as you can see here, the input voltage is with this protection diode. The input voltage comes in here and goes in through here. It's an integrated circuit inside the voltage regulator. I'm sorry, I don't exactly know what it consists of, besides I know there's a Zener diode and I believe some type of MOSFET built into this that allows it to create 5 volts. Side note, it will not step up voltage. So if your batteries are weak, and let's say that those batteries are only putting out 4 volts, you'll only get 4 volts to your Arduino. So it will not help you in an under voltage situation. I have other solutions for under voltage situations. But back to the pinout. This is your ground rail coming out of the center, and it's going down to the bottom power supply rail of the breadboard. And this is your 5 volt output, and it is going down to the positive of the bottom rail of the breadboard. I have a LED to demonstrate that that's where the 5 volts is coming from, that it is functioning properly on my breadboard, so I also included it on here. In the field you wouldn't need this, but I like to add lots of fail-safe. So let's say, oh, right now my Arduino isn't working. As you can see with this shield, it's just kind of sitting in there, so that's why I gave it an LED. So I know my power supply is working, but my Arduino isn't getting good connection there. So that's what the LED is for. You always put a resistor on an LED, because an LED is just a diode, just like the 4001 to its left. It's a diode, so you can it will allow a high current situation to go through it without that diode. The resistor. The resistor I'm using is a 330 ohm. That's suitable for 5 volt with a 2.2 volt forward voltage LED. Sorry, I'm ad-libbing all this. Yeah, so there's a 330 ohm resistor in series with the diode to protect the diode from seeing the full 3 amps out of that regulator. It could actually fry the diode and the regulator very quickly without a resistor. I hear my wife and kids coming home, so this might get noisy. And then the Arduino is just powered right off the bottom rail. So back down here to my breadboard. You'll see I have this packed in here really tight because I'm used to it. But this is in parallel with the outputs of my voltage regulator. My 12 volt input is right here. My ground from the 12 volt input is here. This is a shared ground with that 12 volt. This runs through the Arduino. And this is the regulated 5 volt output. And I'm going to disconnect this Arduino, and let's just see what happens if I connect this backwards. Phone says autofocus, so it's not doing a very good job today. Alright. First of all, this is an Xbox power supply, so I don't expect this to do anything but pop my power supply into protection. Yeah, not even hot. So I'm sure if I get out underneath the bench here, I'm going to see a red light. And there it is. So yeah, that's how you use a protection diode. You put it in parallel with your voltage source. You put it in parallel with your voltage source. This being 6 volts of AAA batteries, and it will protect your circuit in case of any reverse polarity situations.